Hi, in this video I'll show you the RF toy, which is an Arduino-based gadget for interfacing with radio frequency modules, such as these radio frequency transmitters and receivers, or the nRF24 transceiver. Using the RF toy, you can build a number of different projects, such as wireless sensors, data loggers, and remote control. The RF toy has a built-in ATmega328 microcontroller, a USB serial chip, and a mini USB port. The microcontroller runs at 3.3 volt, 8 MHz, and is uploaded with an Arduino bootloader. The circuit board measures 1.5 inch by 2.3 inch in size. It has 3 sets of pin headers, which can directly fit a standard RF receiver, RF transmitter, or the nRF24 transceiver. So this makes it easy to prototype with these radio frequency modules without any extra wiring. It can be powered either through USB or battery, which can be selected using this switch. There's a coin battery holder at the back of the circuit board, and this holder fits a standard 20mm lithium coin battery. The RF transmitter and receiver are individually powered through MOSFETs, so they can be programmably powered off to save battery life. The RF toy also has a 128 by 64 organic LED or OLED display and 3 buttons, so you can use them to make a simple user interface like this. There are 15 extra pin headers here you can use for connecting to external components or for breadboard experiments. And finally, there is an audio jack here to output the RF receiver signals to a sound card, and this allows you to record, visualize, and manually decode unknown signal waves. I'll show you an example later. So now let me show you a few quick demos. The first is a demo called the RF recorder. So here I'm using an RF toy and a 433 MHz receiver to sniff and decode signals from the remote control of these wireless power sockets. And I can play back the signal to simulate the remote control. The demo is written using the RC switch library, which can decode signals from many common wireless power sockets. So to begin, I plug in the receiver and then power the RF toy through USB. I can move up or down to select the empty slot. To start recording, I press and hold the on button. Then I press the key on the remote control. So the RF toy will sniff and decode the signal into a binary code. So here is the code for the on signal. I can repeat the process to record the off signal. So once I have recorded the code, I can then just plug in a 433 MHz transmitter to the transmitter pin header, and then I can click on or the off button to simulate the remote control. With this, I can record many different codes. So I can use RF toy as a universal remote control for many power sockets. The second demo uses a pair of RF toys and the NRF24 transceivers to create a wireless temperature sensor and receiver. To begin, I plug in the NRF24 transceiver to each RF toy through the 2x4 pin header here. Then on the sensor module, I soldered a 100K resistor followed by a 100K thermistor between VCC and ground, and use analog pin A1 to read back the value. So this value will be converted to temperature in Celsius and then transmitted to the receiver through NRF24. And then the receiver will show the temperature onto its OLED display. And because NRF24 can work with 3 volt, so I have both modules powered by a 3 volt lithium coin battery. And so as you can see, it works pretty well. The next demo is the same idea, but using a pair of 433 MHz RF transmitter and receiver instead of the NRF24. So the sensor module has a transmitter installed and the other module has a receiver installed. Because the receiver requires 5 volt, I'm powering it through USB. The transmitter can still use a battery, but in this case, I have extended the antenna to extend the transmission range. For this demo, I'm also using the watchdog timer and power down sleep to save battery life when sensor is not transmitting signal. While sleeping, the sensor draws about 100 microamps, which can probably be further reduced, but even at this rate, it can last at least several months with a pair of AA or AAA batteries. As the last demo, you can also use the RF toy to listen to these off-the-shelf wireless sensors such as temperature and humidity, rain and soil moisture sensors, and show the sensor values onto the OLED display. This is where the RF toy's audio out connector is useful. Now, because the signal encodings of these sensors are not published, we don't know how they're encoded ahead of time, and they're completely different from the wireless power sockets. So what you need to do is to use a sound card to capture the signal waves through the audio out, and then manually check the waveforms to find the encoding patterns. I've written a number of blog posts previously to talk about how I reverse engineered these sensors using this particular approach. And the demos provided in those blog posts are directly usable here. For example, I can program the RF toy to listen to this wireless temperature sensor, and similarly, I can program it to listen to these 2 other sensors. So that's all. To find out more, please visit rftoy.racehobby.net. Thanks.